Okay, our next award is the Lifetime Achievement Award. And we are very pleased and proud to present that to the Lockheed Martin Skunk Works. I think for most of you, you know that that's almost an iconic term. The Skunk Works has been around, I've come to find out, over 7 decades. They have really changed the landscape of aerospace and many other technologies, and they continue to do it today. We have here today two representatives of the Skunk Works, Greg Ulmer here, and Greg is the Vice President of Advanced Development Programs, which is, I guess, the official Lockheed name for the Skunk Works. They don't, maybe on official org charts, call it the Skunk Works. What I came to find out from having a chance to talk with Greg last night, and Eric, his colleague, is that the Skunk Works not only innovates things that are impossible, but they also kind of maintain a soup to nuts relationship with the things that they invent. And so they are still supporting platforms like the U-2 after 50 some years, as well as going into many new frontiers such as compact fusion that you'll hear about tonight. Greg is responsible for ADP operations across multiple aeronautic sites, and this includes programs like the F-22, the U-2 I mentioned, the F-35, which maybe some of you have had a chance to see in this wonderful little exhibit area out in front. He was previously C5 Vice President and responsible for leadership in really defining strategic aircraft and airlift. He graduated from California Polytechnic State University with a bachelor's degree in aeronautical engineering, and also holds an executive master's degree in business management from the University of Tennessee. The other thing I learned last night, which happens to be a primary value of mine in business, is you want to do a good enough job, and you want to be out there and impressing your organization enough, your investors, your corporation, that they'll leave you alone. And so I think that, again, something I think the Skunk Works has done very well to be sufficiently excellent that they have continued to remain creative for so many, many decades. With that, we're very proud and pleased this year to present the Lifetime Achievement Award to the Lockheed Martin Skunk Works.
Got it?
Yep.
Well, good evening, and welcome to the Global Vision Center here at Lockheed Martin. The first thing I'd like to do tonight is send my regards and my regrets for Mr. Rob Weiss, who is the Executive Vice President and General Manager for the Skunk Works. He wished he could have been here tonight, but he had some other engagements that came up, so he asked me to fill in for him. So on behalf of Rob, as well as the past and present men and women of the Skunk Works, I'd like to thank the Arthur C. Clarke Foundation in recognition of this award. The Skunk Works is, as Joe just indicated, a 70-year plus organization embedded within Lockheed Martin, and really the ethos of the company is about solving the hard, and we really focus on and build around that ethos of taking on the challenge. And also we are very aligned with the needs of our nation. And so as a company, really at the foundation in the mid-40s, in the essence of World War II, a gentleman by the name of Kelly Johnson stood up the Skunk Works in response to the first German fighter. And he developed the first production American jet aircraft in response to that. Together with our customers, we've really pushed the possibilities when you look at aeronautical engineering type of feats. We talk about the world's fastest jet aircraft designed in the early 1960s, the SR-71, flying 3 times the speed of sound. We talk about the first production stealth aircraft designed in ADP are the Skunk Works, the F-117 in the late 70s, early 80s. And Joe mentioned the U-2, actually designed probably in around 1954, still flying today, still very relevant today. It's the highest flying manned aircraft in the world and continues to be so today. And these are just some of the accomplishments that I can share because unfortunately a lot of the work we do is classified. But the secret work that we do is really the genesis of Kelly Johnson and his 14 rules that he established when he created the Skunk Works back in the day. And they're really focused on three different things. They're focused on quick, quiet, and quality. And in today's world, it seems that we get farther and farther away from those three things: quick, quiet, and quality. We talk about bureaucracy. We talk about really that bureaucracy getting in the way in terms of how responsive and quickly we can be to response. And the quality aspect is very important to us. We still, with that ethos that we have, we still find that we attract around the world innovators and big thinkers. They come around the world to come work at the Skunk Works. And I'm not sure that Kelly Johnson or Sir Arthur ever met or had the opportunity to meet, but I imagine to believe that they shared a very common philosophy, really focused on exploring the unknown going forward. The true magic behind ADP or the Skunk Works is really our people. And so I want to be sure that we recognize the people of the Skunk Works today. That those folks are the ones that this award really goes to. Unfortunately, I couldn't invite all 3,000 of the folks that work across the Skunk Works, but I did ask a group of folks to attend tonight, so if you would please rise and be recognized. I have some colleagues here. And I think, we're here tonight to talk about compact fusion, and I'm going to yield the floor here to Eric, and he'll speak a little further about that. But I would imagine you're asking yourself, okay, Lockheed Martin, Skunk Works, aircraft, wait a minute, that's not quite compact fusion. How do these two come to be? But as I mentioned, our ethos is all about hard. And so it is not a surprise to us. It is very much in our DNA to not only look at compact fusion, but other technologies, some of the things we've talked about earlier tonight. And we're finding that in the future, it's going to be systems of systems rather than individual type of air vehicles in our future. And so ADP and the Skunk Works is very interested in that kind of approach to problem solving. So without further ado, I'd like to introduce Eric Schrock. He is our Deputy Director responsible for technology and product innovation. Eric?
Thanks. So I want to make sure you can hear me. Is this mic on? It is not. Well, I have that switch on, but let's just make sure. Better? No? So you're going to confine me to a podium? That's all right. Thanks. Yeah, this was. I think this seemed to be working. Can you just turn me up? Is that all right? We're good now? Can everybody hear me? Great. I just wanted to, one, I don't hide behind a podium well, and the other one is there are two big columns here, and I didn't feel it was fair to the people that bought these tickets in here and bought those tickets over there to not maybe be able to hear or see me. So I like to move around when I talk, and I want to make sure that I reach everyone. So if everybody can hear me, that would be great. Okay, so this award is all about the future. It's about envisioning the future, and Greg talked about how we're doing some of that, and we're going to talk about the compact fusion work that we're doing. But I would also like to give you a step back into the past so you can understand why we're doing those things. And I want to take you back to a time a little bit before World War II when Kelly Johnson and two other people, one named Willis Hawkins and the other one named Hal Hibbard, they had a really interesting idea, and that idea was for an axial flow turbojet engine that they developed. Now, this was 1939, and there was a lot going on in the world. They took this idea for a jet engine wrapped around an incredible-looking aircraft, a very smooth blended jet aircraft with a canard, the tail in front of the wing. Looked amazing. They took that to the War Department, and they said, think about this. This is where technology is going. And then the War Department quickly looked at that, and they said, Arthur C. Clarke's first law It's impossible. Don't worry about it. We have got a lot of things going on, and we don't need that. We have a lot of propeller aircraft we want to do. So then, fast forward to a few more years later, everybody at Lockheed is real busy making weapons for the Second World War, but German jets are tearing apart the Allied bomber formations with the development of the Messerschmitt 262 that had 2 of those motors because the Germans were working on it. And they said, you know what? Remember that thing Kelly Johnson had done for us a while ago? Let's pull that off the shelf and let's see what we can do and give them a call. So they gave him a call and said, can you make us the most, in a hurry, a very productive, very efficient, very quick jet fighter that we can have practical in the field as quickly as you can? So he did handpick a small group of people. They formed an organization in the back of a shed under a tent in the Burbank area where they were working on all the other things at Lockheed, and under, like Greg mentioned, quick, quiet, and quality. 143 days later, the P-80, the first practical jet fighter, sprang off the drawing board and into flight. So that started the whole thing. And after that, we really can't tell the history of our nation without the Skunk Works being a part of it. I told you I'd get to you guys. And so, you know, you see things like the U-2 where the CIA came to Lockheed and they said, let's see what we can do to try to really quantify the gap in strategic weapons between us and the Soviet Union. The only way to do that was to fly over the Soviet Union. And we knew that the U-2 would be vulnerable. And on May 1st, 1960, it came to pass with Francis Gary Powers being shot down and then paraded on the world stage. But the Russians were so desperate to do that, they were trying everything and anything, not only their missiles, they were sending their airplanes up on ballistic trajectories. Sometimes the missiles hit their own airplanes and shot down their own pilots in their desperation to get a U-2. And when they did that, we had ideas waiting in the wings for the follow-on to that, which became the A-12 SR-71 Blackbird series, probably the most beautiful flying machine ever designed by the hands of man. Maybe I'm biased, I don't know. Ever since I was in 5th grade, I wanted to come design airplanes for Kelly's Skunk Works, so maybe I'm a little biased. But with the SR-71, the A-12 and the SR-71 that followed it, you know, an airplane that went probably, you could say, the most important aircraft of the Cold War, going right over, in many cases, enemy territory, armed with nothing more than a camera and its amazing performance. And it's nice to be around a bunch of people that are technologically oriented, because if I want to talk about something like this and geek out with you, I know you'll let me. So amazing performance when we talk about the SR-71. At Mach 3.2 and 85,000 feet, the pilot still has over 8,000 pounds of thrust, excess thrust that the pilot can use for additional altitude, additional speed, or maneuvering. And those are the reasons why those airplanes were never touched, because even when the bad guys might shoot surface-to-air missiles at them and they would be able to go to that altitude, they still had enough energy in the jet to maneuver right around them. And the missile was so much out of energy, and with its tiny little fins, it couldn't make the move that it needed to do to engage the Blackbirds, and so they could just dodge them real easy. But anyway, thank you for allowing me that. But that's the kind of thing that that airplane could do. And then a while later, in terms of innovation and big steps forward, we took the time to meld the 2 disciplines of aerodynamics and electromagnetics, which traditionally had never really gotten along very well before, into an operational stealth fighter with the F-117 that was virtually imperceptible on radar, and that changed the course of air warfare forever. So, and you can just remember some of the things that were done there in the Gulf War with a vehicle like that. So those are some of the things that the Skunk Works have done, and now all of those things were all, like Greg said, all very hard. They were all beyond what was the commonly accepted ideas at the time that people thought they could do with things like aviation. And they were all done for our national security. And because of that, particularly the latter, right, we tend to be a very quiet, very secluded, some might even say secretive bunch in terms of the Skunk Works. But one thing you can be sure of, and this is a challenge to tell our story, because the Skunk Works story looks great in the rearview mirror, because I can tell you about the P-80, I can tell you about the SR-71, I can tell you about the F-117 and the U-2, and you know, we can talk about more recent successes like the F-35 and the F-22. Those are all great. We can talk about those, but there's so many things that we can't talk about right now. But you can rest assured, and I think Arthur C. Clarke would be very happy, that the skunks are back in their den. And it took us a while to figure out exactly where skunks live. We had a demonstration center. We wanted to call it something, and so we had a contest. Where do skunks live? They live in a den, so the skunks den. So you can rest assured that the skunks are back in their den doing the things that they do in terms of visioning the future and trying to make the next big achievement. And that brings us to one of the reasons that we're here tonight, and that's the compact fusion work that we're doing. So when we talk about being able to imagine the future, one of the biggest challenges ahead of us is energy. I think the numbers go sort of like this. 1.3 billion people don't have electricity. So maybe there's an O1.3b, but those are the ones that don't even have the power. 1.3 billion people don't have electricity right now. The world energy consumption right now is about 17 terawatts, and it's on its way to 28 terawatts, nearly doubling by 2050. And the plan is, let's do that. Let's get that goal by putting in 1,200 more dirty fossil fuel burning coal plants in order to get that kind of energy, because a lot of the places that need that energy, that is kind of the limit of the technology available to them. So that's a big problem. That's a big problem on the world stage, and we try to look at those kinds of problems. But let's talk a little bit about how we got there to that particular problem. So 6 years ago, two of our organizations, one of them our Revolutionary Technology Programs Organization, headed by Charles. Charles, raise your hand with your purple tie, was meeting with our Conceptual Design Organization to think about how we could revolutionize aerospace again. What would the next big thing be? How could we get to the next big thing? And so we managed to remember that all of the big advances in aerospace has always been preceded by some big step in propulsion or in energy. The Wright brothers couldn't have gotten where they were had they not had a lightweight internal combustion engine. We talked about the Messerschmitt 262 without the Germans and von Ohain working on a practical turbo machine, and also Sir Frank Whittle on the English side. We couldn't have had jet engines, and without von Braun and his rockets, we never would have gotten into space. So those three things were big achievements. So what's the next one? What could we do for aerospace that would allow us the next breakthrough? What's that propulsion? What's that energy system look like? And so Charles and his team thought, you know, a compact fusion reactor might be an excellent way. You know, with fusion, what's the energy density? 1,000,000 times, pound for pound, the energy density of fossil fuels. That's a good first step, right? So what if we can do that and harness that power and use that for the next revolution in aerospace? Wow, rule number one, it's impossible. So let's embrace that and see if we can do it. And we started down a path to do that through several different iterations, and that was about 6 years ago, and to look and see. And so that's how we got there, because we were thinking, what could applications be like for the future of aerospace? So talk a little bit about just the basics of fusion, and I'm no plasma physicist, but in my very kindergarten-like explanation, you should probably be able to anticipate, you know, some of the issues with it. The first thing is, in order to get these light nuclei to fuse, you know, we typically use deuterium and tritium, which are two isotopes of hydrogen, so about the smallest atoms you can get. The first thing we have to do is to strip the electrons off of those nuclei so they can get close enough to smash into each other and release an incredible amount of energy. So to do that, we have to heat that gas up to temperatures hotter than the core of the sun, and when we do that, they transition into a plasma state, and plasma being the fourth state of matter. You know, normally we count 3, and that's great, but the fourth state of matter, plasma, is when those electrons dissociate from the nucleus, and they just become a free-range kind of cloud around the rest of the nuclei there. So when we achieve that plasma state through a lot of heat, a few things happen. First thing is that nature doesn't want to behave that way on Earth very often. You know, we want to try to create a star on Earth. That takes a lot of doing, and that plasma by nature is very angry. It wants to settle, it wants to lose that energy, so you have to hold on to it somehow. And it's kind of like an angry drunk or a Tasmanian devil or something, that you have to try to find a way to hold on to it. And that's where the challenge is. A French physicist said, fusion's not hard. All you have to do is find a way to put the sun in a box. So if we can find a way to do that, then all of these problems will go away. We'd be able to have that unlimited source of energy. But that's a huge challenge, and it's been worked on for over 60 years. So, you know, what are we thinking about, and how can that be different to do that? So what we have gotten is a revolutionary approach that we feel has a lot of merit in terms of the way we arrange those magnetic fields to hold on to the plasma. It's something that we've validated through a set of experiments at low power that we're working on. And what we have seen is that the fields behave as we had designed them to be and through some of the simulations that we've run. And our next step is to increase the power and see how that plasma behaves when that angry drunk has a few more beers, when it gets a little more energetic, and to see exactly what happens. So that's kind of where we are, and this does have some promise to see where we're headed. But the best part of this, though, and this goes back to, I think, one of the earlier discussions, the best part of this is that we're not alone in this endeavor. If you looked at Time magazine this week, how many people saw it? Maybe on a newsstand or on the way to the airport. On the cover, it says, "Fusion, energy for everybody, low cost. This time it might work." And then on the back, they have a very interesting product placement for the Ford Fusion. I don't know how they did that. But so that's what the cover of Time is this week. And in there, it talks about people doing this kind of work. And they're looking at alternative approaches to what the fusion world has done. Now, when we say an alternative approach, we mean those that are not currently being done by large government-funded science. As an international community, we are putting billions of dollars into fusion, which is great. And the efforts that these people are doing and our efforts kind of stand on the shoulders of those giants that have come before us in adjacent innovation, taking the best of what they've done. But there's a lot of these other groups taking a look at the problem, some in Canada, some others in the United States, and it talks about all of those. And they're all a little bit different. And they all have the goal, as the magazine says, not my words, theirs, the audacious goal of saving the world. And that's just a great thing to be a part of. Whether or not it's us that makes that breakthrough or not, it's the fact that there's a lot of people on this path, and it's there's so much momentum here that in our lifetime we very well could see this as a possibility. But what it is, it's a high-risk endeavor. It's a high-risk endeavor for everybody doing this. That's why there's a lot of startup-funded type, mentality out there that's working on this fusion problem. High risk, though, with high payoff for a big national need is what the Skunk Works does. And we're real proud to be part of that. And we've been a proud partner with that type of thing for 73 years now and going on. And we all take that very seriously in terms of the commitment we have to our nation and the things that we do as an entity. And because of that, we're looking to the future. We're still looking to the future with problems like this and others. And that's why this award is so meaningful for us. And I just want to take another opportunity to thank the foundation for that on behalf of the Skunk Works. And like Greg said, not just us, not just the 13 of us in this room, but all of the men and women that have been in the Skunk Works ever since this has been around. So thank you again very much, and look forward to taking a couple questions.